Let's also do the example I introduced Gauss's law with. This example, you guys remember this? You have a thin spherical shell. What is the electric field at the center, at this point, at that point? I stumped most of you guys with this, except, actually, you guys, I don't know, second guess yourself, I guess. So I did stump you guys, I think, with all of these. And with Gauss's law now, I'm sure these are going to be so trivial that it's not even funny. And let me convince you guys of this. So let's do that same example of the thin spherical shell. A thin spherical shell. So we have this scenario and it's positively charged. Let's say we have the center. So let's say A, B, and C. The question is, what is E at A, B, and C? Let's say shell has a charge of Q and radius R. So we want to consider the central point. The central point. What Gaussian surface would you want to choose? Huh? Yeah, you will want to use a sphere of what size? Yeah, where would you place it? What do you mean the whole thing? Like this thing?
Sure.
For analyzing A? Incorrect.
Oh, just A.
Yeah, just at the center. A is the center. You will want to use a sphere that is pretty much infinitely small so that the radius of that sphere is the center. If that makes sense. So you're going to be using a really small sphere. And we're going to apply Gauss's law onto that sphere. So that's the area of A, which is equal to Q close over epsilon. Because we're using here's the thing. Okay. Inside this infinitely small sphere, what is Q enclosed? How much charge is enclosed in that sphere? Huh? 0, meaning our area is not 0, so the only conclusion is that the electric field has to equal 0. There is no charge enclosed that is equal to 0. Therefore, we can conclude that the electric field at that point is also equal to 0. What about for B? You would want to use a sphere that just touches B. And once again, what is the Q that's enclosed there? So here. So that's A. What charge is enclosed in that sphere?
0.
Right, 0. But the area is not 0, meaning what does the electric field have to be? This means the electric field has to be 0. Yeah.
What do you draw different spheres for A and for B? I was like, for B as well, why do you have like an infinitely small sphere like we did for A?
So remember the sphere has, what's the surface area of a sphere?
It's 4
Pi r squared. If we want to consider a certain point, this r has to go through that point of interest. Does that make sense?
Yes. So, well, why don't we just draw a sphere around B then, with B being the center?
You mean here?
Yeah.
Well, one, at that point, that's not true anymore. Because from here, we would have electric field, like you lose this aspect of symmetry. We have a sphere and a sphere here, like you would have electric fields kind of coming in at different angles, right? And this angle is not going to be the same, it's not going to be, let's say, radially symmetric,
Okay.
if that makes sense. You get what I'm saying?
I think I do, yeah.
So if we have this sphere versus this sphere, all that angle and that angle is going to, the electric field is coming from here. We have that going out there. Okay, technically the angle is 180, but that's another way of saying 0 or negative 0. So for every electric field, they're going to cancel. Whereas if you had it slightly offset, let's make it super obvious here. This versus the electric field that will be going in would be like that. And you see that the angle is not 180 degrees off.
Right. Okay.
Does that make sense?
Yeah.
And so at that point, that opens up another possibility. So E dot A, remember, is equal to E A cosine of theta. There's another way in which, even if Q enclosed was equal to 0, if cosine of theta is equal to 0, you still satisfy that identity, and you can't conclude that the electric field would be 0.
Right, okay. That does make sense. Thank you.
Alright, what about at point C? We want to use this sphere. And here, you would get EC dot A Q enclosed over epsilon naught. What charge is enclosed? This time there is something inside, which is Q. What is the surface area of our sphere? It will be 4 pi r squared times the electric field at C. This would be equal to Q over epsilon naught, meaning the electric field is going to be Q over 4 pi epsilon naught r squared. So pretty much it behaves as if it was all of this charge was condensed onto a single point, because what expression does this look like? That of a point charge. All right, well, this is all we were able to get to in the calculus class, and so we will end it here.
So this this K equal to 1 over 4 pi epsilon naught?
Yeah.
Okay.